something has recently happened. Glowing steam hisses from hairline cracks in the sand, rising in pale ribbons that twist through the morning air. Fishermen along the shore say the ocean here has started behaving strangely, with the water near the docks bubbling as if something deep below is heating it from within. At first, it was a curiosity. Then it became a warning. The coastline has risen, and scientists are surprised. Now it feels like the coastline itself is trying to speak. The mystery behind what's happening beneath this Californian beach is something no official map accounts for. There are no labeled volcanoes here, no long-recorded magma chambers, no crater fields. And yet, new seismic sensors are detecting signals that have experts arguing in circles. The ground is rumbling in patterns that could be linked to a hidden fault line, while chemical readings suggest something hotter, deeper, and far more ancient might be rising toward the surface. If it's a new fault, this coastline could be poised for an earthquake that would impact millions. If it's magma moving upward, an uncharted volcano may be forming beneath the waves. No one can say which is true, not yet, and time may not be on our side. The coast where the earth never sleeps. California's shoreline is dramatic, not just for its cliffs and golden sand, but because it sits where two of Earth's massive crustal plates meet, the Pacific plate sliding powerfully past the North American. Their friction shapes mountains, opens fractures, and causes sudden quakes that can strike with no warning. But farther offshore, another force moves more quietly. Underwater volcanoes, some buried beneath thousands of feet of pressure and cold black ocean, can push molten rock upward, heating the water above. The nearest known one, the Axial Seamount, lies roughly 700 miles northwest of San Francisco. It's a restless structure, swelling upward at a measurable rate of nearly an inch every month. Every few years it erupts, but never in ways visible from the shoreline. Researchers track Axial using a web of underwater cables, pressure sensors, and remote data relays. One of the scientists leading that work, William Chadwick of Oregon State University, calls the volcano a living laboratory. The signals exist, Chadwick says. You just have to know how to listen. Pressure changes, seafloor swelling, heat pulses. It's like the volcano is breathing. Recently, the same kinds of signals, heat, seismic tremors, and chemical shifts have begun appearing alarmingly close to the California coast. And the source is far from clear. A coastline with long memory. Long before modern sensors, this shoreline had a reputation for strange ground. In the late 1700s, Spanish missionaries wrote in their journals about sulfurous vapors rising from the sea after tremors. They described sand too hot to stand on and the sharp sting of volcanic gas in the air. But the local Chumash people had known the coastline far longer than any missionary. Their stories warned of breathing sand and earth that moved when angered. Their oral history described these events not as supernatural, but as patterns. The earth is giving signs. Then, in 1908, after a moderate earthquake, a fissure opened along a beach near Los Angeles. Witnesses reporting rising mist and a burning mineral smell that clung to clothing for days. The newspapers called it a curiosity. Locals called it a message. One of those locals was the grandfather of Bill Cooper, a resident whose family has lived near Portuguese Bend for generations. Cooper remembers his grandfather's advice. The land here has a memory. It shifts, it grumbles, and every so often, it reminds you that you're only borrowing the ground. The coastline is speaking again, and this time, the signs are sharper. The coastline is changing faster than it should. Recent time-lapse satellite imagery shows something astonishing. In less than a single summer, a new tongue of land has appeared at Portuguese Bend. Beaches that once sloped gently into the surf now jut forward, reshaped by forces rising from below. This is not erosion. This is not storm buildup. This is the Earth moving upward. Infrared scans reveal a faint but unmistakable heat plume beneath the new landform. The sand is newly exposed, raw in color and steaming on cold mornings. the coastline is expanding and doing so unnaturally fast. For scientists, this kind of rapid change leaves no room for casual interpretation. The evidence demands answers, and quickly. Inside the field tent, a scientific standoff. Two scientific camps now face each other across folding tables and buzzing laptops. Both groups are looking at the same data, but drawing wildly different conclusions. Group 1, the fault team. They argue this is tectonic. The ground here, they say, is acting like a loaded spring, a landslide zone shifting from internal stress. The seismic patterns look like brittle rock movement, not magma. No fresh lava has breached the surface. The coastline shape resembles known slide patterns. Their case is logical. Group 2, the magma team. They counter with chemistry, and chemistry rarely lies. The steam venting from cracks in the beach contains helium-3, a rare isotope that almost exclusively originates from deep within the Earth's mantle. Surface water and groundwater cannot create that signature. The sulfur levels are elevated too, along with sharp metallic gas odors that match volcanic vent chemistry. Then there's the heat. The ground is too warm for a simple landslide. No tectonic slip cooks the coastline like this. The debate has become a stalemate. Both explanations fit parts of the evidence. Neither fits all of it. And so the coastline remains suspended in uncertainty. Pressure, not just underground. Scientific confusion would be challenging enough, but pressure is mounting from outside the lab as well. Developers, tourism boards, and local officials have watched the story spread online. Drone footage of smoking sand, beachgoers filming strange bubbling surf. The optics are bad. The economy is vulnerable to bad headlines. Within days, drone flights are restricted, data access requests are denied, terminology is softened in public statements. Official language shifts from anomalous heat event to natural sediment disturbance. But some residents, like Bill Cooper, aren't convinced. Last time they told us it was nothing, the road collapsed. So forgive us if we'd like the truth sooner rather than later. Behind closed doors, risk assessments are being drafted, rewritten, and debated line by line. No one wants to be the one who causes panic, but no one wants to be the one who stayed quiet too long. The meeting that changed everything. October 15th, 2025. No cameras, no press release, no public calendar notice. Inside the County Emergency Management Office, officials, scientists, and USGS leads gather around a table crowded with seismic charts and isotope analysis reports. The data is noisy, the conclusions are messy, but the stakes are unmistakable. Dr. Meredith Gage, who heads Coastal Hazard Response, lays it out clearly. We do not have proof of a volcanic eruption, but the readings fall outside every baseline we have. We acknowledge both earthquake and volcanic risk. We prepare for both. And just like that, a dual advisory is drafted. The community is informed. The coastline enters a new phase. Watchfulness, preparedness, acknowledgement. No more dismissing the signs. Where the story stands now. Monitoring has been expanded. Gas sensors and seismometers now transmit data in real time. University labs review chemical samples daily. Emergency agencies rehearse response protocols. And yet, the root cause remains unconfirmed. The coastline is still changing. Steam still rises on cold mornings. Tremors still pulse beneath the sand. Is it a hidden fault waking up? Is it magma slowly pushing toward the surface? Or could it be a combination, a tectonic system cracking open a pathway for something deeper to rise? No one can answer yet. What can be said with certainty is this. The coast is moving, the ground is speaking, and this time we are listening. The next chapter will depend on what the sensors reveal and how quickly we act on what they say. Because the Earth doesn't send warnings without reason, and this shoreline has a very long memory. Make sure our channel rises by hitting that like and subscribe button and follow more content like this.